Okay, in this video I'm going to try to go from the moon back to the Earth, and my goal is to get back to the Earth and rendezvous with the International Space Station. The normal way one might go about this would be to take a normal trip from the moon back to the Earth, and once they get back to the Earth, to then do a plane change to get in plane with the ISS and then rendezvous. That's okay. It's not very efficient, but you can do it that way. If you've got a limitation on fuel, or if you just want to do things more efficiently, then you really want to take into consideration the idea of arriving back at the Earth already in plane with the ISS, so that you do not have to do that really expensive plane change once you arrive back at Earth orbit. So let's go about trying to solve that problem. So the first thing we need to do is to kind of find out when the best time to leave the moon is. And the best way to do that, if you press F3 and select the ISS and switch over to the ISS, you can bring up Map MFD and make sure that it's referenced to the Earth. Click on Display, change the orbit lines to Orbit Plane, and then you're going to want to target the moon. And we are targeting the moon from inside of the ISS. So just kind of understand what's going on. We are, at this point, our vessel is the ISS, and we're inside of it. The best time to get back to Earth so that you can arrive in plane with the ISS is when the moon is at one of two positions. It takes about 14 days for the moon to go from one position to the other. And as you can see here, I've already sort of got this scenario set up a little bit. I have the moon, or I have the time already set where the moon is in one of these proper positions. If you kind of zoom in on the map a little bit, you can get a really good idea of exactly where the moon's at. Let me kind of, just to point this out, you can see the moon isn't quite perfectly over top this intersection. It's really close, but it's not quite there. And that's kind of what you want. And it can be at either of those intersections, that intersection or that one. So if the moon happens to be somewhere along this path, you just want to fast forward time, use time acceleration until the moon is, to that point. And by the way, if you happen to be sitting at the moon in the XR2 or XR5 or some other vessel that requires oxygen or cooling, then make sure that you have that vehicle set up with external cooling on, like I've got here, because if you fast forward time several days and you don't have external cooling on, then you could potentially run out of liquid oxygen. So the next thing to do then, once you know the moon is in the proper position, is to begin planning a path, to begin planning a plan to get back to Earth and then arrive in plane with the ISS. There's probably a few ways to do it, but the best way, or at least one way, the only way that I really know, is to use transects. So I'm going to start transects on both sides. This is pretty common to do with transects. When you start transects, if you're not familiar with how it looks, then take a look here, because this is what it should look like by default when you're starting it up on the moon. It says MAJ moon, that's the majority body, is the moon. And it'll be in stage 1-1 on both sides. The view will be set up. It'll say VARS, stage 1, and planets, moons, and so on. So the first thing we need to do with this setup, just how it is we're going to click plus to go to escape. And we could actually do that on either side. At this point, TransX is in the same state on both sides, so it doesn't matter which side we do this on. It'll update on both sides. After we have it set to escape, I'm going to click forward. I'm going to do that on this side. And at this point, TransX is in 2 different states. So from this point forward, we're not going to be making changes over here just yet. We're going to be doing changes on this side. So once I have TransX on this side set to this state, let's take a moment to just kind of understand what this is that we're looking at. Now we have the major body as the Earth, and the minimum body is the Moon. And it turns out this in the center, this is actually the Earth. And this blue ring around the outside is the Moon's orbit around the Earth. So this tiny thing in the middle is the Earth, and this line is pointing to where the Moon is at in its orbit around the Earth. I just think it's important to understand what it is that you're looking at, because if you don't understand what all this stuff is, then it all becomes so abstract that you can't really make any sense out of it. So the next thing we're going to do in order to set up our plan to rendezvous with the ISS back at Earth, so we're going to change this planet's moons. We're going to adjust it to ships. You can see if I click ADG, or ADJ rather, it's going to adjust it to ships. If I click it again, it goes back to planet's moons. And once it's set on ships, then I'll click the plus plus sign, and it'll bring up this dialog box. And I can type in ISS. And that will have that set to the ISS at that point. Now I need to set up a couple of variables to make TransX appear how I need it to appear in order to give me information that's useful. I'm going to go to graph projection, and I got here just by clicking var several times. And I'm going to click plus to get this to set on plan. I'm going to click var again until I get to scale to view. I'm going to change that to target. Now it's kind of important to understand what we're looking at again, because things changed fairly drastically all of a sudden. We're looking at something very different. Whereas before the Moon was that big blue circle on the outer edge, the Moon is now, or rather this blue circle is now the ISS, and this gray circle is the Earth. So whereas before the Earth was that tiny thing in the middle and the Moon was the blue circle, now the view has changed, and it's important to understand what we're looking at, because if we don't understand this change in views, then we don't know what's going on. So this is now the Earth, and this blue ring is the ISS. That is the orbit of the ISS around the Earth, and this is kind of a 3D view, so you can see it's sort of going kind of around the equator there. I guess that would be at a slight angle. And this line represents where the ISS is at in its orbit around the Earth. If we sat here and waited, or if we fast forwarded time, we would be able to watch this line go around the Earth every 90 minutes. Okay. So the next thing we need to do is begin inputting some information that will allow us to get back to Earth. And the first thing we're going to do is input some negative prograde velocity. And this is just the normal way that you would get back to Earth from the moon. And we're going to click the negative negative, and we're going to bring this down until we see this dashed yellow ring here, which represents our hypothetical orbit around the Earth. Currently that would have us impacting with the Earth. So I'm going to change the adjustment to fine and move that out a little bit. And something like that should be pretty good for now. It doesn't have to be right on, but something like this has us coming back to Earth and puts us approximately at the orbital altitude of the ISS. And don't worry about getting this too accurate at this point because things are going to change. Okay, in this video I'm going to try to go from the moon back to the Earth, and my goal is to get back to the Earth and rendezvous with the International Space Station. The normal way one might go about this would be to take a normal trip from the moon back to the Earth, and once they get back to the Earth, to then do a plane change to get in plane with the ISS and then rendezvous. That's okay. It's not very efficient, but you can do it that way. If you've got a limitation on fuel, or if you just want to do things more efficiently, then you really want to take into consideration the idea of arriving back at the Earth already in plane with the ISS, so that you do not have to do that really expensive plane change once you arrive back at Earth orbit. So let's go about trying to solve that problem. So the first thing we need to do is to kind of find out when the best time